So
Thanks.
I have started the recording. You're free to
Okay,
start.
okay, okay. Thank you for attending this seminar or a small talk about our recent work. Yeah. I will be excited to share our recent work that called OSWorld. So it is work that benchmarking the multimodal agents for open-ended tasks in real computer environments. So it is just archived about 2 weeks ago, and you can see some people like make some PR and share their views. And here we want to talk about more um, technical details and analysis in this small talk. So I hope you enjoy and feel free to ask any question if you want. So let's make a small introduction that this is an example from my advisor Tao Yu that that take IKEA furniture assembly, for example, that for every student that study abroad or maybe start a new home, the first thing they do may be like buy some or order some furniture from the IKEA, and they will receive a box that contains a small book that is the assembly instructions and some like piece of woods that what they do next step is they assemble the these pieces of woods into a assembled chair or tables or their bed in a few hours according to the simple instructions. So the instruction may demonstrate in a few ways that combine the illustration of the including the modality of the images and the text. So as shown in the left. So this is actually a interesting topic that we focus and the whole NLP community focus nowadays that it is called planning. So it is actually a detailed annotation of the step-by-step plans. And the left side is, as we shown, is the tool set that you may have some tools that provided, such as the hammer or other things that you can use to assemble these chairs. So the people have the intelligence that they are intelligent enough to grounding on these instructions and to make this assembling. They can turn this page of illustrations to put together all the things to make this assemble furniture. Well, it is the same thing happen in the computer task in the digital world. Like we also feel like see these scenarios that sometimes we want to make some small changes or to make some operations on our computer that we may be not familiar with or we forget how to do it. So for example here, how do I change my desktop background on my laptop, such as the MacBook? So on the Mac OS environment, maybe the first thing you need to do is to like searching for some documents, whether officially or other kind of unofficial documents on the website. And by screen and ops website, you may get some clues and you ground on this website. You hold your mouse, you press on your keyboard, and you make these operations through the mouse and keyboards, and you finish this task. So while you macOS change with the new wallpaper, and this task is finished. So we are wondering about that whether the large language models or vision language models can be used for this task as well. So we a basic step that we do is to let's ask with the GPT-4 or ChatGPT. Like we ask, how do I change my Mac desktop background? That its answer is very detailed, but it is only the response of text-based response that it told us that to first click on the Apple menu, second click on the saver, third you will find blah blah blah, and 4 and 5 and you are finished. So the same way as the IKEA chair, that if you ask the ChatGPT about how to assemble an IKEA chair, it will also give you some plans or even the detailed steps that seems very make sense, that you can probably the human beings, the normal user can probably draw some insights from his response and try to finish the task by themselves. Well, it seems that the ChatGPT is able to generate step-by-step plans that could be useful. So whenever we input some instructions, it can generate some fruitful insight. Maybe it is due to the its inherent ability that it is trained on the website that store this knowledge inside its weights that it can output according to your scenarios. But what they cannot do is that they cannot execute tasks on your Mac by grounding plans into actions. Like it can only do the description on the task, but you are the one that it's supposed, the ChatGPT is supposed to do this task by yourself, and it cannot help you do this task. So you can never expect, and the OpenAI may not expect the alignment on the making the ChatGPT or the GPT-4 to becoming the actual executor of the this agent task. So it cannot hold your mouse and your keyboard to help you to change the new wallpaper. And it can, of course, cannot hold your hand or make some humanoid robotic or some other kinds of formats of robotics to finish the furniture assembly. So here we our lab propose interesting direction that we call it the Epsilon. So we are wondering that what if we can make these agents based on the large language models and the vision language models to take human instructions and grounding these instructions into the real environment to output some actions varying from the SQL Python code, maybe the select con star from table, or some API calls, which OpenAI previously called it the plugins. Maybe here the shop API, and with the parameters that the name is truth or other things. And it certainly it can also generate some web or app controls, such as you click on the coordinates that with 100 x equals to 100 and y equals to 100. And you can also output some robotics controls that maybe you grasp something with the speed equals to 1 and the force equals to 5.0. And we can further execute these actions into the environments, such as the data, web, apps, mobile, desktop, or even the physical world, and to get a new observation and iterate again and again. Of course, we can hold some tool from the toolkit, such as the SQL interpreter, Python interpreter, the robotic arm, the calculator, or Hugging Face API, or other model weights, or other things. And through that, we can solve the previous challenging task that we cannot model through the previous single inference, like we call it single observation and single action ways, such as the maybe input output ways, to solve that in these new formulations. And that's what the Epsilon would like to do. So yeah, just a few background knowledge. What is an intelligent agent? Here's a screenshot from the book that called from the poem pulse that called the artificial intelligence. That here it shows that agents is the sense that perceives one at a time and maps the perceived sequence to a sequence of discrete actions, so that it uses a sensor to take the percepts and make actions onto the environment to execute this action. So the sensors, to be more concrete, it may be some camera or screenshots or radars according to your application scenarios, whether it is you want a digital agent, or you want a self-driving car, or you want like humanoid robotics. And its core is its brain that it may be served by the large language models or the vision language models or some neural symbolic stuff in the future may design by ourselves later. And it can also have some effectors, maybe the robotics arms or the code interpreters. Yeah, and the environment could be like, as mentioned, according to your application scenario, such as the computer, mobile, and physical world. So here, in the robotics community, that one paper called the Code as Policy have make some progress that format the actions into the code to finish some tasks. And we extend it to become more, as we mentioned before. And we focus on the directions that it could be made to achieve more broadened scenarios such as the data, webs, mobile, and physical world. Okay, so yeah, so the challenges and the abilities it may for the agent may need to have is that first it need to have the ability to abstract user instructions, and second it need to have the ability to utilize the tools to expand capacities, and it also need to explore complex unseen environments and multiple steps on the planning and reasoning. And it also need to follow the feedbacks and make self-debugging. So the agents may need all this kind of ability to make it enough capability for facing the real world scenarios. And our recent work for advancing the natural language interface with language model as agents are shown as below, ranging from the instructor to Bender, Lemur, open agents, textual roles, and today we'll talk about the OSWorld. Yeah. So yeah, the OSWorld is a joint work by many authors, collaborators, and from different institutions. So yeah, so we propose autonomous agents for computer tasks. That computer tasks often involve multiple apps and interfaces. So take this example for instance, like it is the example that we want to update the bookkeeping sheet with my recent transactions over the past few days in the provided folder. Like the left side is a initial state of this environment that the sheet is open and it has the previous records of the my transactions, and the agents need to first minimize this window, and it need to check the desktop on the this computer, and it will find out that there are some recent transactions, and they will click them one by one and make the perception clearly. They have to look into these details and have the ability to extract this information, and finally it has to return back and fill this information into this sheet by predicting current coordinates and predicting current clicks and taps. So it's quite challenging. But yeah, its main challenge is that for the benchmark, the major challenge is that there's no such real scalable interactive environments for modeling this kind of real world scenarios. Like we mentioned two works, that the first is the man-to-web. So yeah, we call it static benchmark, that it only contains the demos without executable environment. So it contains no execution-based evaluation, and thus it cannot support the interactive learning or real-world exploration. And another work also on the web agent scenarios that called WebArena, that it contains the environment varies from like some sampled scenarios, but the environments are limited to specific apps or domains because it only focuses on the website itself. So it simplifies the agent observation and action spaces, and limited task scope cannot support the evaluation of complex real-world computer tasks. So here, OSWorld, we propose the first scalable and real computer environment, which can serve as a unified multimodal agent environment for evaluating the open-ended computer tasks that involve arbitrary apps and interfaces across operation system. So here we will dive into the more details that the task formulation is shown here, that first we have a task instruction. So as shown here, the updated bookkeeping sheet with my recent transactions over the past few days in the provided folder, that we input this task instruction into the agent, and the agent is responsible for interact with the environment, which is a real computer environment that with different operating systems such as the Mac OS, Ubuntu, or Windows, with arbitrary apps such as the folder, other system stuff, or VLC for video playing, and GMP for image editing, and Chrome for web browsing, like Thunderbolt for email checking, and then Sheet and PowerPoint or VS Code for coding. And it's also across the interfaces such as the CLI and GUI, so the graphic user interface and the command line user interface. And after the agent decide it fail on this task or it's done on its task, so finally it's draw its conclusion or it's reached the maximum steps of the setting, and we will draw the final state of the environment, and our evaluation script will decide whether this task is accomplished successfully or the task is failed. So yeah, later we will tell more details about how we did in these steps. Yeah, one thing we need to be specially noted that it contains it is specialized in observation and action spaces that make it more realistic, while also offer more challenge for the agent, that it is based on the screenshots and accessibility tree as the input, and it's predict raw mouse and keyboard as the output for each turn of the agent interaction. Yeah, here is some definition stuff that yeah, we will skip this for this moment, and we will show here that the action space here is actually clicking, for example, for the mouse clicking, is actually clicking on the certain pixel of the screen, such as the click 300 and 540 with the button right. So, and the observation space here is the raw screenshot with, you can see, is what human perceived, and accessibility tree with the human may have some disability that they need to they need to operate on the computer. Okay, so next step we'll tell more about more details of how we did in this environment, what happens in this environment to enable this kind of real computer tasks for the agent training, evaluation, and further learning, or other things that you may be interested about. So the first step is that giving a computer task instruction, such as here the updated bookkeeping sheet, as we mentioned before. And we will have a task initial state setup config, as we shown here, and marked with different highlight color that including the you can see here the we will download some bookkeeping sheet and open some sheet. Yeah, and we also have evaluators results and functions config, which we will discuss later. And with this task initial environment state setup, our task interpreter will interpret this download and open actions into the environment, and to prepare this initial state, so that the initial computer is empty, is with nothing, and our interpreter will interpret this initial state setup into this scenario, into the state that you see on the left of this page. And the next step is the agent takes the task instruction as input, and the environment will offer its observation with the screenshot as accessibility tree. And we will have an example here that for the screenshot, we may contain the raw screenshot that without this bounding box here. And as you may all know that for currently, it is one method called the settle mark that may draw some bounding box on each button or text box that may augment the multimodal model on the attention and make it perform better. So that we also have an example here that for demonstration. So anyway, it inputs the screenshot. And for the accessibility tree, the raw accessibility tree contains many of tokens, so that it needs some like trimming on these trees to significantly reduce on the tokens. So it's another research direction that laid for others. And here we just use some heuristics that method to retrieve some very useful buttons, such as a button that is clickable or text box that is able to take some input or other things. You can see more details in our code. And agent is responsible for predict the mouse and keyboard actions, and the environment will take this mouse and keyboard actions as we shown here, that we contains the full capabilities of any humans can do on the computer. We formulate the actions in that way, and we let the agent to generate in that way as well. So which means that if the agent is powerful enough, they will not be blocked by our action space and observation space, that it will be capable to generate any kind of action that human beings can do to finish any task that human beings can do. So we will show two examples. We will first look at the right side of the action space here, that it includes the move to, click, right, press, hotkey, scroll, drag to, key down, key up, and three special actions that we add into the this called the wait, fail, and done. So the wait is that the agent decides it should wait for a few seconds to wait some actions on the computer to take effect. And a fail, it may happens that the agent think this task is infeasible to accomplish, such as some features of the software may be outdated, and or some hallucination that caused by the human user, that they think it is the function that can be operated, but they're actually not. And also the done. So the agent decided the task is finished. So here are also two examples on the left side, that it can click on the Chrome X and Chrome Y, that click on some points to open the Chrome apps. And the second example here, as shown here, is that it can typewrite some commands in the terminal, and maybe later it will click some hit on the enter to execute these commands as well. Yeah, and for example, we will show a full example here, like monitor the system CPU for 30 seconds and output the results. So it will output the sequence like first click on the terminal X and terminal Y, and second click on the focus X and the focus Y, and typewrite some commands, and it's done. Okay, so that's the action space and observation space of the agent of the environment that we provided. And after interactions again and again, and finally it finish all these steps, we will have the final step, the evaluation. So it is very important that in an executable language that we have the realistic environment, but also the reliable evaluation. So how do we do in our evaluation? Like it is very special and distinguish us with other benchmark that we wrote one task specific evaluation script for nearly every single task. So we have the example-wise evaluation script to make our choice on the examples more flexible and diverse. So previously, you may have the one exact match matrix for the open domain QA, or you may have the execution accuracy, the pass 1 or pass 5 for the code generation task. But for now, we are handling a more complex and maybe full of possible task that called computer task. So it needs more different modeling of the evaluation that you can handle the task around the computer. So here, for example, that consider about the task here that can you help me clean up my computer by getting rid of all the tracking things that Amazon may have saved? So to decide whether the agent have finished this task, that we have the evaluation function that check about the cookie. We first get a cookie from the environment, which is a virtual machine. And secondly, we use some rules to check that whether the inside these cookies, the role that fits the slot that fits the role with the domains with the Amazon.com is deleted. Yeah, so that's this evaluation script. And for the second example, such as the rename sheet 1 to some names and make a copy and place the copy blah blah blah. So we have for this sheet handling task, we have a different strategy of evaluation script that we first get a file, and secondly we get a golden file from the cloud, and we compare this sheet through our compare table function to this and we take input some special requirements which we call the rows here, and we output the final results. So consider about statistics. You can have a roughly grasp of our benchmark here. That as a result, we collect 369 real-world computer tasks, or we can say computer environments that involve real web and desktop apps in open domains, including the OS, the file I/O, and professional office, daily workflow, etc. It not only contains the GUI, but also contains the CLI and their combination. Sorry. So each task example is carefully annotated with one real-world task instruction from the real users, and an initial state setup config to simulate the human work in progress, so that when you need a digital agent to help you to finish the task, sometimes you will not start from the beginning after you start your computer. You are in the middle stage of some work. So we try to mimic that scenario to make our agent task more realistic. And the third is that we also have a custom execution-based evaluation script, as we mentioned before, a very carefully annotated execution-based evaluation script, which is very reliable for evaluating that whether this task is finished or not. And we have more statistics as shown here, and you can check on our website and paper later. So what is distinguish us among all these benchmarks? We divide that into a few different aspects, ranging from the previous agent benchmarks such as the Gaia, Agent Bench, Intercode, and the other, maybe the web agent focus, the GUI operation focus benchmarks, such as the ranging from the earlier work such as the mini warp to the recent work such as the work arena, visual web arena, and web arena and Omniact, so that we to distinguish with them, that we have a large, relatively actually a large of the task types. You can see here that actually they have like more than like 10,000 of data examples, but most of them are generated through one or maybe a couple of hundreds of templates and fill in some different value slots. But our tasks are not done in that way. So every task in our benchmark is very special. And our executable environment is focused on the computer, which model the whole digital task in a unified way, that you don't need to like focus on the code or focus on the web or focus on the mobile in an isolated way, that you can try our environment and handle them all together. And also we highlight our scalability on the environments, that we not only provide a benchmark, that we also provide a paradigm that you can scale your environment in this way, that you can annotate a initial state setup config, you can annotate a executable based evaluation scripts, so that you can annotate any example that you need in our environment or in maybe some later environment that in that way. And of course, the multimodal is about for maybe in the next year or the later of this year, there will be much more powerful multimodal foundation model to support this kind of digital agent or other agent. And we also distinguish them that we are cross apps. So it first fits more on the real scenarios, and we also have intermediate initial steps. And lastly, we have more than 100 evaluation functions that others may not have. And to demonstrate our difficulty of our OSWorld environment or benchmarks, that we did a human evaluation that shows compare with the previous very famous web agent benchmark called WebArena. That our task contains a lot of example that require human to take more than 10 minutes to finish this task. And most of tasks, the median of our tasks is the over 100 seconds, while it is only over half a minute for the WebArena. And our accuracy for the human is much more lower than there. Yeah. So next we will talk about, okay, so how do the current large language model or vision language model agent baselines do in this benchmark? So we use a prompting way, that we wrote an instruction as shown on the right side, that we told these large language models or vision language models to act as a digital agent, that you can output PyAuto GUI code, and you cannot do certain things, and you can do certain things, and additional knowledge such as my computer's password and other information to control the format of actions. So after inputting this, we carefully choose from the large language models and the vision language model from the open source ones, such as the Mixtrail, mixture of expert version, and the Coq agent, which supports specially optimized for the high resolution scenarios. And we also choose from the most powerful closed source models, such as the GPT-4, Claude 3 Opus, and the Gemini Pro vision and text versions. So yeah, so we fix the temperature of 1.0 and the top P of 0.9, and we provide the most recent 3 observation and action pairs as history contents for each step. So we call it history encoding, and later we will show whether it is important. So we choose different according to the perception, that we have 4 choices. That the first is the basic accessibility tree, that it is only required the model to with the text input ability. And then the screenshot, so it is the same perception with the human beings, that we take the snapshot and we output the actions. And the third is the screenshot plus the accessibility tree. So to see whether this this complete modeling can help in to which extent. And we also test on the settle mark, which makes some bounding box on the screenshot, and we also input a detailed information, which is a table of the coordinates and the size of the bounding box together with this annotated screenshots into the model to see if the set of marks works on this our OSWorld environments on these tasks. So the result is shown as on the right. That here is some takeaways. That first is the large language models and the vision language models are still far from being digital agents on the real computer. So the most advanced result among all these settings and all these models is only about 10%. So, and this 10% is actually the most easy part of our environments, such as maybe you don't need the agent to you may not need an agent to modeling this kind of things that you can barely generate multi-step of code to finish this task. So yeah, and then the second takeaway is that the agent performance is in different distribution with human performance across the different types of the computer tasks. So that as shown at the below, that human performance overall is over 60%, and it is consist among all these subsets, such as the OS, Office, Daily, Professional, and multiple apps workflow. So it is consistent all around the 60. So yeah, I mean that some tasks are really difficult that maybe is not enough for normal human that are not familiar with this task to do, but it is consistent. But for the language model and the visual language model, you can see that they failed on they got significant low results on the subsets such as the Office and workflow. So they may infer some like the distribution shift or like some ability shift among the current visual language model and language model with the humans, and may infer some mechanism or other ways for us to do research. And the third takeaway is that the accessibility tree and SOM's effectiveness varies by the models. So you can see that the Gemini Pro, the GPT-4, and the Claude 3 Opus, like with different input settings, like their performance is quite different. And we found that maybe it's some models may not good at taking the set of mark as perceptions, and some model may be excel in inputting only the accessibility tree. And the fourth takeaway is that the VLM agents with screenshot only settings show very low performance, but it should be the automated configuration in the long run. So that if you see this full part of 4 different settings, you can see the screenshot holds the lowest result. That the other settings for the best models, such as the GPT-4V and other models, it got performance over 10. And for the screenshot, they are struggling in performance around 5 to like even 0. According to our observation, that even for the GPT-4V, they cannot predict a current coordinates that you can only see it's hung around and click randomly on the screenshot on the screen and make some nonsense actions. So yeah, but we mentioned that it's the ultimate configuration since all human beings are do this task in that way. But for now, it has no ability on this kind of tasks for the vision language model and the visual language model on the screenshots. Yeah, we also did some result analysis of the language model and the vision language model baselines. So the first is that the first takeaway is that the higher screenshot resolution typically leads to improved performance. That we this setting is that we adopt the GPT-4V models and input with 2 settings such as the screenshot only setting and the SOM settings, especially one and we adapt the downsampling with different ratios on the screenshot before we input this screenshot into the vision language model. And except for one a special point for the SOM, which we suspect that it may due to the reason that there are a lot of in pre-training data around this size with bounding box. So it may be the best for the GPT-4V to do SOM on that. Except for this point, so you can see a trend that it's if you do the more downsampling you did, that which makes the image more smaller and the low performance you will get. And we further analysis on the due to the analysis on the context length. So which extent do the accessibility tree do the tokens consumed by the accessibility tree if we want to formulate the task in the pure text way or a mixture of the accessibility tree and the screenshot way. So how many tokens does this method take? That we calculate the distribution of some sample tasks that the result is that to hold at least 90% of the accessibility tree, that your model need to support at least 6,000 tokens to input the accessibility tree as perception. And the longer text-based trajectory history context improve the performance. And unlike the screenshot only history, but pose efficiency challenges. So we mean that for the SOM setting of the GPT-4V model, that we input more observation action pairs from the history, from the current step, that the last step and the last step before last step, we input more of this history encoding trajectory length, and we got better performance. And combined with the distribution of the accessibility tree, that you may need more efficient and more the models with more capability of the tokens of the long context models that you need to have to support this kind of usage. And the next thing is that we found that we also did some experiments on the not only the Ubuntu operating system, but also on the Windows operating system. And we found that first thing is that the performance of the visual language model across different operating systems is in strong correlation. And this implies that the insights and methodologies developed with the OSWorld benchmark can be effectively transferred to Windows environments with a high degree of the reliability. And we plan, currently we only public the Ubuntu image, and we are in the very near future, we will also release the Windows ones, but may need some activation from the user side. Yeah, and the next result is that we did some distribution to the environment that in different aspects, ranging from the positions, that we may change in the positions of the window from time to time to see if it affects. And we also change the size of the window, such as we may minimize some windows, or we may drag its border to make it not the minimized, but as much smaller as it can. And we may also add some clutter that irrelevant windows open some irrelevant applications to make some disturbs. Okay, and we found that the current VLM agents are not robust to UI layout and noise. So originally we choose a set of the tasks that the agent may be good at, that have the 50% of accuracy. And after we made this disturbs, and it's dropped significantly, especially for the size disturbs, that we see a drop of nearly 40% of the accuracy. So and you can see the paper for more interesting analysis that we showed. We did a lot of analysis in this paper, in this work. And surprisingly, that we see some successful case of the large language model and the vision language model agent baselines. So here, that is an example of the extract the subtitle from a video that the agent successfully opened the terminal and ran the code of the MFF and PEG to extract the current video. So it requires like some software knowledge and coding knowledge and some GUI interaction ability and even some memory stuff and exploration stuff. So, but it's done by the current digital agent. So it is like, but as we shown, the performance is quite low. So there are still many challenge stuff we can do, many challenge point that we can try to overcome in the near future. Yeah. So thank you for listening, and here are some future research direction that you may interest about. But if you have some question here that we can discuss more, since time is, yeah.
All right. So thanks, Timbo, for the exciting work and the talk. It's very detailed. And okay, I'll stop the recording, then we can start the QA session.